Welcome back here with me, with Nick to do maths. Welcome minions, math magicians. We are away from the floating head, back in studio. We are going to solve a pretty nifty, gonna need a red pen, differential equation here. Now, our usual techniques are no bueno. This is non-linear, etc., etc. We're going to get powers of y, dy, dx. Ooh, a bit tricksy, but we are going to look for a substitution because there is something that looks funky here to me because I've got a little bit of symmetry here. And importantly, something might happen if I can divide the numerator and the denominator by x. Because I end up with 1 minus y over x over 1 plus y over x. So this suggests to me that maybe I make a little change of variable. We're going to make the change of variable v is y over x, okay, which tells me that y is xv. Now, we're going to take this change of variable and we're going to whack that into here. So let's differentiate this. We get dy dx is differentiate the x, keep the v, keep the x, differentiate the v. And we can plug all of that in. So my differential equation now becomes v plus x dv by dx is equal to 1 minus v over 1 plus v. And actually, this is separable. We can separate the variables on this. X dv dx is 1 minus v times 1 plus v over 1 plus v. So what do we end up with if I tidy this up? I end up with 1 minus 2v minus v squared. Okay. So let's reconstitute all of this into one big, nice differential equation. We probably do also want my initial condition, which is when x is 1, v being y over x is 1 over 1, v is 1. All right, so let's see what we can get. Now, if we separate the variables on this, I'm going to get up here 1 plus v over 1 minus 2v minus v squared dv is equal to 1 over x dx. Okay? There we go. Now, one thing we might realize here, of course, is that is basically the derivative of that. All right? All I need instead is a minus a half on this side. If I just multiply both sides by minus 2, maybe that works. Minus 2 minus 2v, 1 minus 2v minus v squared dv is minus 2 over x dx. And now I've got a function and its derivative. So this is beginner. This is going to become ln of 1 minus 2v minus v squared is equal to ln x to the minus 2 plus some constant. Now we can find that constant quite quickly, but we'll first get rid of the ln's. 1 minus 2v minus v squared is a over x squared. Here, a is e to the c, essentially. Just a different constant, just calling it something different. Right, so x is 1, v is 1. 1 minus 2 minus 1 is a over 1. Tells me that a is minus 2. All right. Okay. Now let's turn the v's back into x's, shall we, or shall we not? We could just make, yeah, let's complete the square on this side. Let's complete the square on this side. So that becomes minus v plus 1 squared plus 2 is minus 2 over x squared. So really what we're going to say is that's 2x squared plus 2 over x squared is equal to v plus 1 squared. V is plus or minus square root of 2x squared plus 2 over x. Now, at this point, we can actually decide which branch we need just by my initial conditions. When x is 1, v has to be 1. When x is 1, v needs to be 1, so this needs to be the positive square root. Multiply everything by x. Because xv is y, so we end up with y is negative x plus square root 2x squared plus 2. And I just think that's beautiful. Cool little change of variable, lots and lots of lovely maths playing around. We do need to be a little bit careful, but because of my change of variable here, I do need to be a little bit careful what happens at x is 0, because v blows up when x is 0. So I probably do need to have a little double check here, but I think we're okay. And again, we have a little issue here when x is 0 anyway. So maybe x can't be 0? What will happen when x is 0? When x is 0, dy dx should be minus 1. But v would be 1, so x can't be 0, so that doesn't work. Cool. Yeah. All right. So there we have it. Nice little, I say nice little, pretty cheeky little differential equation. Change of variable, coming up with it, doing a whole lot of stuff. Love it. Please don't forget to like, subscribe, hit the notifications so you know when the next one of these is coming up. Let's keep those brains going. Let's keep doing some further maths, doing all this fun stuff. It's what maths is for, isn't it? See you soon.